Hello friends, welcome once again to the tutorial series on the Pixlpal firmware. In this particular video, we'll be talking about creating a template app. In the last video, we briefly explained the layout of a Pixlpal app. This video will go ahead and demonstrate how such can be created using a template. Going forward, the template can be used as a basis for developing new apps or even more complex apps. We'll dive right into it. The template app will be created within the examples app folder. So we'll go ahead and start off. You create a new folder and we'll name this folder app. Okay, this is the convention we use, preceding the folder name with app underscore templates. Yeah, we can leave it with this name, or we just call it a template app. Okay. Within the app, you need two key files at least. First is the C++ file, which will contain the implementation of your app. So I would go ahead and create a new Pixlpal templates app.cpp. Okay, I would make that a small letter for the purpose of consistency. So going on, another file you need within the app, or a template app, or any app whatsoever, is the CMake lists file, which is a text file containing key parameters, which informs the compiler as well as the linker. It informs this on which resources within the ESP-IDF you would like to use. Such resources include the Arduino core, if you wish to use Arduino core APIs, as well as some other Metabit components, such as the Metabit engine component located. This is it. So all applications have to specify, especially the engine component, because creating app requires APIs from that component. So we would go ahead and create the CMake lists file within the template folder. So new file, which has to be named precisely CMake lists.txt. As I mentioned, the CMake list is used by the compiler slash linker of your ESP-IDF environment to include the necessary components folders you need for your application. So you register the components which you would need for your application using the following syntax: IDF component. Okay, my Copilot assistant is already suggesting the parameter or the syntax, which I will just, okay, let me just type it, or there's no point. I'll just go ahead and accept that. So you start off with sources. This is a parameter, and what follows are the files which your application is made up of. These files will be compiled. You are simply specifying what should be compiled and linked. So recall, we created a Pixlpal template file. We'll simply copy the name of that file and specify it within the CMake list as a source file. So I'll replace this. This is our only source file. We equally, if there are other directories within the file, within the app which you would be using, I'll go ahead and create one as an example, which will be an include file. Most times you have contents within the include file for complex application where you may need to implement, produce API implementations in multiple files. So to keep your program organized, you may require an include file, especially for those familiar with C and C++ programs. However, for this application, we'll leave the include file blank. As this parameter indicates, which directories would you like to include? Would include the name of our include file here. The third parameter, there are others, but these are the three key parameters to get you started. Is the requires. I would accept that from Copilot. However, you are required to specify which components you would want your application to make use of. Now we'll be using the Arduino core. Most application, if not all, will at the point make use of the Arduino core library, which is quite extensive, having a lot of useful APIs for embedded system programs. So I would include the Arduino core, and I will include the Metabit engine API, or rather components. So these are the, ensure the spellings are correct. Yeah, Metabit engine. So Metabit engine. That will be it. These are the three key parameters you need for a typical Pixlpal application. I'll go ahead and save this file. Now within our template app, we have the CMake lists file, as well as the Pixlpal template application C++ file. Within your C++ file, go ahead and include #include. Start off with Arduino core. Arduino, okay, it's a capital letter. Arduino.h file, and include Metabit engine.h. So these are the two key files you need for a typical Pixlpal application. Next, as we mentioned, each Pixlpal application is a FreeRTOS task. So we create the handle, external RAM ESS attributes, task handle, which Copilot is already suggesting the definition. So yeah, this is the convention we use for defining this is the task handle, which we assign it a null value. Then the Pixlpal application task, which will run continuously, being a FreeRTOS task under the hood. Next will be the assignment or definition of the object. That's the Pixlpal template app object. This is already being suggested by Copilot, so I would just accept that and explain. So for this particular app, there are two app implementation templates, which is you can either make use of full screen app, where the app will have no status bar at the top, or you can make use of a status bar. I would, for this particular template, we use the status bar app class definition. So you create a pointer whose type is the application with a status bar, and make sure these both are aligned. So this is the constructor which will construct our object. Does initialize the object and assign it to this pointer. Here we have the application task. That's the task function. And mind you, in C and C++, before you go ahead to use a function, you must declare. This is called prototype function prototype declaration. It must be specified at the top of your file just before you go ahead to make use of that function. That is why we have this. The implementation will follow under. We've assigned the handler to this particular object, as well as the name of our application. Moving on, we can go ahead and implement the app task, which is a FreeRTOS function. As you can see, this is already being suggested by Copilot. I'll just go ahead and accept the suggestions because they are actually correct. So at the onset, we receive this parameter on start of the application. This function is the FreeRTOS function is called task, and this parameter is sent in. We cast that parameter into a metabit application, which is what is done over here. We'll be using this macro. Yes, sense is for consistency. The macro is simply a text. I will just quickly go to this. It's simply a text, which is this app. So to make reference to the particular application which owns this task, would always use this convention. So moving on, for the purpose of this application, we would simply just go ahead and initialize the app. This app, use your arrow operator and initialize the app init. The app init for this template app will carry an empty parameter. When we develop even more complex app that requires other services running in the background, we would see how other means of initializing an application. but for the purpose of this template app, we don't need that. Now for the template app, upon app initialization, you can just dive right into the continuous loop, which is defined thus: while this application is active, this is equally a macro, and while the app is active, pd true. This pd true is an RTOS definition for true, similar to the C++ implementation of true. So while this is true, or you can make this while it's 1, but for consistency, just use the FreeRTOS definition of true. Okay, let me just show it to you. If we go to the definition, you can see this translates base type 1. So while it's true, what we'll simply do is print to the console. Okay, let me just accept these suggestions from a Copilot. Okay, while the application is true, I would use the C print definition, that's printing a text to console, which appears thus: print F. Okay, I would just accept this suggestion by suggestion by Copilot, and what we'll do is we delay for 5 seconds before printing the message again. Then we exit the loop for further implementation. At this point, you clean up. Now your main application runs within this loop, as most embedded system projects. For any reason, when the app is no longer required to run, this parameter will become false. I would go ahead and show you the full implementation, this macro. It already appears if I hover around the macro. So its full definition is this app, arrow operator, app is running. So when that parameter becomes false, it causes the app to exit. So we would move on. So we clean up the resources by calling the function. Okay, I'll just accept this. We call the function mtb delete this application. The parameter you pass is this application, which was casted at the onset. That's at the beginning of the app. So you simply copy this and make that your parameter. You close your function, and that is it. What we've implemented is the full body of an application, of a Pixlpal application. Now, there are instances where you may create some other variables within the application that occupies external memory. By external memory, I mean the memory of those variables are not on this function, on the stack of this function. So those cannot be freed automatically. In such cases, just before you delete the application, you free such memories. Down here, we'll demonstrate at a later example how to do such. So just before you free your application, make sure you free all resources. Now we will go ahead and save the file, then attempt to compile the program to make sure we don't have any errors or bugs to compile, you simply click on the build project. I would expand this. Now this compiles successfully. However, we would attempt to run this template and see what happens. Coming to the main function, mtb launch this app. Okay. Now I would attempt compiling once again. Now, when I attempt to compile, you notice the error given, which let's see the error message. Pixlpal template app was not defined in the scope. Now, this is an error arising due to the fact that the main file, the file containing the main function, has no visibility to the application we just created. That is, it doesn't recognize the app template component which we created over here. To solve this issue, you simply add the component name, which is the name of your directory containing the component files. You add it to the CMake list of your main directory. I'll close this so it becomes more visible. So we can see the main directory here, which has its own CMake list file. Would go ahead and include the template, the name of the template component. That's the file directory name, app underscore template app. As soon as you do this, you save and you recompile. But just before we do that, now, in as much as we've included the component within our main CMake list, you still have to specify a parameter telling the file to search for this particular variable within the entire program. And to do that, you simply use this C or C++ syntax extend. You follow that with mtb applications. Remember, we made use of a status bar application, and then finally the application is actually a C pointer, so you equally include that. So this is the syntax. What this does is to tell this file, when at the point of compilation, to search the entire program for this variable. Now, this file will be able to search for this variable since it's been specified. The location of that particular variable have been included in the CMake list. So I'll go ahead and compile once again. Hopefully there will be no other errors. Okay, now how the ESP-IDF works: whenever you make changes to files, those are program files, C or C++ files, when you recompile the compilation, it takes a short period of time. However, when you make changes to CMake list files, it takes a little longer. Now, if this was the very first compilation where we don't have the build folder, it would have taken much more longer. However, we already have the build folder, so this would only work to link new components. We can see we don't have any errors so far. at this point. When the program compiles successfully, you can see the squiggly line has disappeared, and this particular variable is now being recognized within the main file. Our program has compiled successfully. We'll go ahead and run it and watch how it reflects on the Pixlpal device. Mind you, we are not printing anything to screen. We'll just see this text being printed to the console based on this app template. So I would flash and monitor using this button. As was mentioned, the button flashes, compiles, and monitor. Now, when flashing commences, you will notice on your Pixlpal device, the status LED turns bright blue. It's usually an indication that the device is in download mode. So flashing is in progress and flashing has been completed successfully. So the Pixlpal restarts, initializes, and upon completion of initialization, you should begin to see the text which we specified in our app templates appear every 5 seconds. You can see it, and I'll just read it very quickly. Hello from the template app. This is where you can write your own code to create a new app for Pixlpal M1. You can use the MTB engine functions to interact with the system and create your own unique app experience. So this prints every 5 seconds as we specified within the template app. Now notice the free internal SRAM text being printed also. This is implemented within the main function, as can be seen here. In the next tutorial, we'll quickly brush up on the various means to debug, that is a print text. Here we can see the printing of text using the Arduino serial.print API. However, within our app, we made use of the C API. There are other means to print out text, or the third means is using the ESP-IDF APIs, which is more robust. I would quickly just show it to you. In the next tutorial, we'll discuss in details how to go about using those APIs to debug. Back to the draw shape apps example. This is the syntax for the expressive debug or text debug API. We'll touch on this during the next tutorial. As you can see within our screen, the application executes with the status bar showing our template app, and by default the status bar shows the current time and current date. However, you can specify if you want the weekday to appear instead of the current time, or if you don't want any information to appear on the status bar at all. This video is about 30 minutes. We'll stop right here. Thanks once again for listening. See you in the next one.